Hello, hope you're all well. Okay, page 116, number 98. Says the limit as x goes to 1 to the positive side of square root of x squared minus 1 over negative, or the inverse secant of x, which will give you 0 over 0. If you remember, the graph of the secant looks like this. So here's 1, it turns up and has an asymptote at negative pi over 2 and pi over 2, and then at negative 1, the bottom half of the graph. So it never reaches the x-axis. And if you remember, the secant of theta is equal to c over a, right? And as c goes to 90 degrees, as theta goes to 90 degrees, a goes to 0. That's why you have the asymptote. So the graph of this, of the inverse secant, is going to look like, this is going to be pi over 2, which is this asymptote here. Here's 1, and there's negative 1. Right, so you have negative 1 here, 1 there. Remember, with inverses, the domain of the original function becomes the range, and the range becomes the domain. So we convert this to x squared minus 1 in parentheses to the 1/2. Take the derivative, it's L'Hopital's rule, take the derivative, you'll get 1/2 of x squared minus 1 to the negative 1/2 times 2x over 1 absolute value of x, square root of x squared minus 1. Look at your formulas for derivatives, this is what you'll get. So this becomes x over x squared minus 1 to the 1/2. The 2's will cancel, divided by 1 over absolute value of x parentheses x squared minus 1 parentheses to the 1/2. So when you do the division, you're going to invert it, and the x squared minus 1 to the 1/2 will cancel. You'll end up with x times the absolute value of x, which will give you 1. Take a look at number 99. Pause the video. Alright, problem number 99 is the limit as x goes to infinity of x times tangent, the inverse of the tangent function 2 over x. It's going to give you a form of infinity times 0. Right, because as this goes to infinity, it's a number divided by infinity gives you 0. This is an indeterminate form, so you can use L'Hopital's rule on it. But you got to do an algebraic manipulation because you want to either convert it to 0 over 0 or infinity over infinity. So if you look at page 102, where it starts next, about 2/3 of the way down, read what it says there. The answer to this problem is 2. See if you can figure out what algebraic manipulation you're going to do here in order to solve this problem. Alright, on page 116, I want you to look at problem 116. I want you to try to work it out on your own. It's not in the solutions manual. The answer to the problem is 42.22 degrees. So give that a try and see how you do with it. Not as difficult as it looks, but it's not easy either. Alright, let's turn to page 149. Now on page 146 are basic integration formulas. I want you to look at number 2. The way you can reconfigure this so that you can apply a basic integration formula is divide the numerator by the denominator. So go ahead and do that and see how you do it. See how you get it. Simple 4th, 5th, 6th grade arithmetic. Alright, when you do the division, you get x squared divided by x squared gives you 1. 1 times x squared is x squared plus 1. Subtract, you get a negative 1. So it's going to be negative 1 over x squared plus 1 is remainder. You can now write this way. So you can divide it up into two integrals. So go ahead and integrate that and see what you get. Don't forget to use the table. Pause the video, try it. Alright, so I integrate 1, I'm going to get x. Using number 19 on page 146, the basic integration formulas, this will become tangent, the inverse tangent x plus c. Take a look at number 4. Give it a try. First thing you want to do is substitute u in for tangent of x. So go ahead and do that. Find out what du dx is. Right. Do that as your next step. Alright, so the derivative of u is secant squared x. This means du is equal to 1 over cosine squared x dx. So when I substitute it back in, it'll be cosine squared x du. These will cancel. I'll end up with 1 over u du. Now I have to change the upper and lower limits. When u is equal to tangent of x, when x equals pi over 4, u will equal 1. The tangent of 45 degrees is 1. When x is equal to pi over 3, u is equal to the square root of 3. So I have 1. Okay, substitute those in, solve it, see. Alright, this is going to give you natural log of the absolute value of u. The upper limit is square root of 3, bottom one is 1. I substitute them in. Natural log of 1 is 0. This is the natural log of 3 to the 1/2, which becomes 1/2 natural log of 3. Try problem number 8. Let u equal natural log of z to the third. See how well you do with that one. Pause the video. Alright. I'm going to write it u equal to 3 times natural log of z. Take the derivative of it. It's going to give me 3 over z dz. I don't have a 3 here, so I'm going to, when I substitute in, I have to have 1/3 du is equal to dz over z. I have my dz, I have my z. I don't have my 1/3. I'm going to take the 16 and put it outside and multiply it by 1/3. I get 1 over 48. 2 to the u. U is now the natural log of z to the third. So try the formula 5 on page 146. See how you do with that. All right, take a look at number 10. All right, number 10 is 8 over x squared minus 2x plus 1. Integrals lower limits 1, upper 1 is 2. Going to have u equal to x minus 1. So give that a try, see if you can figure it out. It's not that easy to figure out. All right, if you figured out how they get that, congratulations. That's not that easy to do. Now use the formulas, you'll find out that this will equal the inverse of tangent u. Now you have to alter the upper and lower limits. So when x is 1, u is going to be 0. When x is 2, u will be 1. So make sure you don't forget to change your upper and lower limits. All right, problem number 12. What you want to do is use long division. Divide 4x squared minus 7 by 2x plus 3. So go ahead and do that. Pause the video, see what you get. All right, when you divide through, you should get 2x minus 3 plus remainder of 2 over 2x plus 3. So it ends up looking like this. Now what you want to do is integrate each one separately. So go ahead and try that and see what you get. Pause the video, give it a try. So you should have this. Now go ahead and try to integrate each one. See how you do with it. Pause the video. Okay, final answer. This is going to become x squared, 3 to the negative 1, minus 3x, upper limit 3, lower limit. For this one, you have to have u equals 2x, which means du equals 2dx. You have your dx, you have your 2, so you can put in the du. You have to change the upper and lower limits. When x is equal to negative 1, u is going to be equal to 1. When x is equal to 3, u is equal to 9. Integrate this, you get natural log of u, upper and lower limits there. Plug them in, you'll end up getting negative 4 plus natural log of 9 equals natural log of 4 plus 2 times natural log of 3. This is perfectly alright, or if that is, you want to. Alright, let me put your homework on the board. You're going to be getting a test pretty soon. Alright, your homework assignments, page 116, numbers 97 through 99, numbers 109 through 112, number 116, page 149, number 1 through 5, and numbers 7 through 12. Have a great day.